Okay, well, this is as far as we're allowed to walk now. During mid-May until mid-June of 2018, I could drive in here and drive down to the Halemaʻoma'o parking lot to collect ash from buckets there that was collecting ash, and also to examine the development of the cracks along the road. And these cracks just beyond the gate here were smaller than they are now, of course, but nonetheless it required me to kind of slalom around them because you couldn't just stay in the same lane all the way. And then finally things got too nasty and had to back off from there. This road cut here is the only place in the national park now where you can see a cross-section of explosive deposits that from the last 150 years of the past explosive period, from about 1650 to the early 1800s. It's the only place, unfortunately, that you can see that. I know that you're not concerned about the details of these deposits, but I do want to tell you some things about them because it's such an important part of Kilauea's history. Virtually every bed there would reflect a separate explosion, or maybe several beds could be lumped into a series of closely spaced explosions. Any of these explosions, had you been here, would have been lethal to you. The explosions, we think, were mostly driven by heated groundwater, the steam hypothesis, but we can't be sure about that. The exposures here in the road cut extend from about 1650, as I said, and this deposit here, up to a little bit younger than 1790. So we have, 150 years of Kilauea's history exposed here. Now, the work that's been done in the past 20 years has shown that the explosive part of Kilauea's history is far more important than we realized beforehand. And it turns out that explosive periods and effusive periods can be recognized. By that I mean that there were periods of time lasting a few hundred years in which the dominant kind of eruption was an explosion. And then that period ends and you start into a period dominated by effusive eruptions, or the eruptions of lava flows with few explosions taking place. At Kilauea, since the early 1800s, we've been in an effusive period. And that's one reason that people didn't realize that the explosive part of Kilauea's history was so important. But if rather than being in the early 21st century, as we are now, 2020, but if this were, say, 1720 or 1620, our view of Kilauea would be very, very different. This would have been quite an explosive place. There were no lava flows being erupted up here at the summit or anywhere that we know of. And the caldera was very much deeper than it is now, except for the Halemaʻoma'o part. And so things were very different. And we just need to realize that and try to understand the changes that have taken place. Now, I've done a lot of work trying to correlate Hawaiian chants and oral traditions with the eruptions. And we can't see the earliest explosive deposits, which I think the chants describe quite nicely. It's an R-rated story, so I'm not going to tell it here, but I published it actually in a scientific journal, so if you're into R-rated stories, you can read it there. But it tells, I think, about the development of the caldera after a long period of lava flow extrusion. There were 150 years, the caldera formed about 500 years ago, and then 150 years of explosive deposits. The oldest one of which we can see here is this one. And this is a very different kind of material than was erupted either before or after the eruption. This is scoria, resembling in some manner the 1959 scoria, except that 59 is very glassy and this is not glassy, not very glassy at all. Then you go up above that and you get into this unit here, which has lots of accretionary lapillae in it. They're little balls of fine ash stuck together when they were wet, indicating a wet eruption. And then you get into a lot of different layers, as I said, each major layer at least probably reflecting a significant explosive eruption. And then the prominent ledge below the gravel is the footprints ash, and the gravel is related to the footprints ash. We'll talk about the footprints ash and the gravel just right up here at the end of the outcrop. That's 1790 deposits. But I want to talk about this one here a little bit, because this one also has significance to Hawaiian culture, I think. This is a deposit that came from a high lava fountain. This is a map showing the 1959 Kīlauea deposit, and this is the outline of this deposit. This went very much farther down toward the southeast and came from a column height we think was 10, 12, 15 kilometers high. This deposit, I think, relates to one of the famous stories that is told frequently about a battle that Pele was having with an erstwhile suitor of hers named Kamapua'a. Kamapua'a was a really handsome hunk at times, but Pua'a means pig in Hawaiian, and he was literally a pig at other times. So he had a changing schizophrenic personality. One time, as the story goes, Pele and Kamapua'a were having a big fight, and Kamapua'a finally poured a lot of water on Pele to try to put out the fire, drown Pele. And Pele almost succumbed, but she finally mustered all of her strength, and she rose up out of the crater, and she threw rocks at Kamapua'a and chased him all the way to the ocean. This is the deposit that is the only one in the relevant time period that sent rocks as far as the ocean. You can now, where the Chain of Craters Road reaches the coastline, makes its big bend, you can find small outcrops of this deposit down there, still half centimeter to centimeter size rocks in that deposit. And so I think that that is the eruption that produced this deposit here is the one that Pele used to send Kamapua'a away. And that would have taken place in about 1650 or so, based on carbon-14 dating that we've done on charcoal above and below this deposit. So parenthetically, I might say that I think that Pele's reputation for having a terrible temper derives from this period of explosive activity. What do some of us do when we get angry? We throw erasers or dishes or something, right? Pele was angry, I think, and that reflects a temper that I don't think is reflected by the slow effusion of pahoehoe, of lava flows. So I think it was this period of time from about 1500 to the early 1800s that really gave Pele her reputation. And probably the first part of that was the most important in deriving Pele's personality. Now, and so then after 1650, just as before, there were lots of repeating explosions until we get up to the most famous one of all, and that's 1790. And we'll go take a look at that next. Okay, well, we've now reached the deposits that I think are related to the famous or infamous lethal eruption in 1790. And I want to go through the reasoning related to this eruption, both because it's an interesting sort of detective story, but also I think it tells us what could happen in the future. This layer here, which you can see, it extends farther along the outcrop here. It's very prominent. It's the same one that we could see along the road farther up. That is a fine ash deposit made of fine ash and little spherical BB size and a little bit bigger balls of ash that are stuck together. They're called accretionary lapilli or pellets or whatever. And they are pretty good evidence that the ash was wet when it was falling. Whether it was wet because it was erupted wet, or whether it got wet in the air as it fell through rain, is always the big question. But it was wet when it landed. There's even better evidence than the geologic evidence that this was wet. That is at other localities down the southwest rift zone, in another lobe of this eruption. There are thousands of human footprints indented on the surface of this deposit. We've tried to figure out something about the people who made the footprints. So we've measured the size of almost 500 footprints. The footprints have to be well preserved to do this, but we were able to find almost 500 footprints. And what you do is to measure the length of the footprint, and these were all, of course, barefooted people. You measure the length of the footprint from the back of the heel to the tip of the big toe. That length will be 15% of your height. Measure your feet tonight and try it. Check it out. There's very little plus or minus with that. You know, it's pretty amazing. So we did this. We measured footprints, and it turns out that when you calculate the height of the people who made the footprint, the average height is 5 feet. Now, contemporary Europeans, or Europeans who arrived in the 1820s and missionaries later, commented on how tall Polynesians in Hawaii were relative to the European heights, and a very famous missionary, Titus Coyan, estimated that the height of human warriors averaged 5'10", and male skeletal remains over in Kona have been pre-European contact remains have been found at average about 5'8" or so. So when we calculate a height of 5 feet, those are women. Most of the footprints were made by women. Occasionally you can see just tiny little footprints. There's one place that I know of where there was a woman's footprint, and right alongside there's a little child's footprint. It's as if she got tired of carrying the kid and plunked him down on in the ash. There are taller people, of course, men involved, and the ratio of men to women is something on the order of 1 to 4, 4.5, something in that order. Sort of family grouping size. But anyway, so the footprints, people were walking on this wet ash, mostly women, some men, for 20 kilometers down the rift zone from the summit area here. It must have been kind of horrifying walking on this wet, slippery, and the air was probably still chock full of fine ash and so forth. Now, what also occurred around the summit, not where most of the footprints are, is that the eruption of this material up here took place. And the footprints ash was still so wet and soupy that rocks from this eruption plunked into and sunk into the footprints ash. So if you go up here and look, or any place where you find the footprints ash in the summit area, you can find that there are rocks embedded in it that sunk into it from this second eruption. So that means that the time between the eruption of the footprints ash and the time of this unit, which I'm going to call unit J1, was short. Minutes to a few hours, probably. Otherwise, the footprints ash would have dried out quickly. As we know around here, when the sun comes out, you get, the mud dries very, very quickly. So I would say that these two events were very closely spaced in time. But how do we know what year they were? How do we know that it was 1790? Well, the story is this. There was a marooned English sailor up at Kauai at the north end of the island. He was keeping a ledger. Well, the reasons for why he was marooned there are suspicious. We don't really know why. But anyway, he was there keeping a ledger. And in his ledger, he wrote that early in November, he saw a cloud rise and tower above the summits of Mauna Loa and Mauna Kea. He said the mountains. And well, in order for him even to have seen the top of the column from where he was, we know where he was in Kauai, the column had to be about 19,000 feet high, and it was towering over the summits. So Jagger and a lot of people, including myself, have all estimated that the column height was probably at least 30,000 feet high and 9 kilometers high, and could have been a lot more than that. So what's the significance of of John Young, the name of the marooning? He said, what's the significance of his observation? Well, that means that the upper half or so of that eruption column, carrying ash with it, got up into the jet stream. The jet stream, the subtropical jet stream, blows across Hawaii at elevations of between 4 and 15 or 17 kilometers above sea level, out of the west, northwest, north usually, year round. It doesn't change direction as it does in many tropical areas. At least that's the way it's been for as long as records have been kept. So if you get if John Young sees an eruption column 9 or 10 kilometers or more high, that means that the upper part of that column got into the jet stream, and so that the ash would be blown toward the east and the southeast. Now, this contrasts with the trade wind direction that I showed you a bit ago, that would go toward the southwest, because the trade winds are blowing out of the north and the northeast. Instead, this is not this deposit, but it had a similar orientation. It was blown by the trade winds toward the southeast. So what you do, what this does is to go southeast, young woman, go southeast and look for deposits, ash deposits, and you find them. There are ash deposits interbedded in soils and usually bioturbated into the soils, and so it's kind of a mess. But you find rocky material in this organic soil down there, and then you start walking back toward the summit area, digging pits along the way and examining. What you find is that the youngest of those ash deposits in the southeast correlates with this thing up here. You can walk right into it with J1. I found J1 now as far as Kaimu, and it's still going. I gave up there. So since that's the most recent of these deposits, and it corresponds to what John Young saw with the colonite, we assume that this is 1790. And by extension, then, the footprints ash, which was still wet, is also 1790. And the footprints were made in 1790. So, what happened in 1790? Well, there was sort of a conflict going on for supremacy of the island. Kamehameha and was rivaling his cousin Kīlauea. And they had a skirmish at the north end of the island, and then Kīlauea had gone down to Waiakea in Hilo and got wind that of Kamehameha's advance down the Kona coast into Kīlauea's home country of Kau, down towards South Point. And so Kīlauea mustered his forces together and started across the volcano. Hawaiian forces brought their families with them, so there would be a lot of women and children as well as their warriors with them. They got up here to the summit, and Pele was angry. Huhuloa. She was throwing rocks. And so they couldn't go beyond for 3 days and 3 nights, and finally, there apparently was a break, and Kīlauea split his forces into thirds. The first third got through unscathed. The second one was totally annihilated, and the third group was injured. Some of them were, but for the most part survived. So just the middle group was just in the wrong place at the wrong time. This probably occurred on the west side of the volcano because there was a main Mauka Makai trail there, the mountain to the seacoast trail, and that's where all the footprints are. So it seems as if that's where the fatalities were, somewhere close to the summit, along that old trail. There's a place out there where I found a large patch, maybe about as big as the area we're sitting on here now, just trampled with footprint on footprint. You can't measure the size of any footprints because they're one on top of the other. And I just wonder if that isn't a place where a lot of fatalities occurred. Yeah. What caused the deaths? We think it was a pyroclastic surge that swept across the western, especially the southwestern flank of the volcano. We find surge deposits there that are just younger than this fall deposit here. And I've mapped them out, and it's not a terrifically large surge, but it certainly would have been hazardous. A surge is a rapidly flowing hot mixture of gas and rocks, air. It moves at hurricane velocities across the landscape, and is one of the most lethal kinds of volcanic events that can occur. At Mount St. Helens in 1980, there was something called a lateral blast, which was a surge. It turns out we would now apply the term surge to that killed 57 people. And then the condition of the bodies suggests that they were killed by a surge. Now, all this was written down several decades after the fact, so you need to take everything with a grain of salt. But the description of the bodies is that the bodies were in, the skin was scorched, but in no place deeply burnt. That suggests a rapid passage of hot. They weren't bombarded with large rocks, so it wasn't falling ballistic blocks that got them. And one of the most intriguing things to me is that the later missionaries put their spin on it. They found people, corpses were found clasping onto one another. And the missionaries said that they were holding on to one another as if they were taking final leave. And I have a more practical solution. I think they were trying to keep from being blown away by this hurricane velocity surge. It was blowing past them, and they had nothing else to hang on to except themselves. I've seen this on videos taken of typhoons in Southeast Asia, and you'll find that people are grasping onto anything, light poles or whatever, or to themselves, to keep from being blown away. So I think that's what was happening. So I think that a surge probably related to this eruption, but emplaced just sort of at the end of that eruption, is what killed the people. It killed a large number of people. The estimates range from about 80 men to about 400 countrymen to 400 warriors to 800 warriors. All these estimates are for men. The warriors had their families with them. So I just figure that there were a few hundred people killed, probably, by the surges, within a kilometer or two of where the former HVO site was. So I told this story because it's kind of interesting how you can piece various different kinds of observations together, but it tells you the kind of thing that can happen in the future. And if it can happen, it probably will happen. Maybe not in the lifetime of anybody, of any of us now, though you can't be sure. But surges can occur. They can be very important. And although there haven't been that many large ones at Kīlauea in the past, if one occurs at the wrong time, when people are around, bad things can happen. So that's the story of 1790. A tragic event. Because that was so, the 1790 event made such an impact and killed so many people, it was thought before 20 years ago that all of the explosive deposits that we were looking at down there and even earlier were related to this one eruption in 1790. And so you'll see a lot of older papers, including a geologic map of the summit area here that refers to this as 1790 deposit. And it's an important part of the deposit, but as you can see, it's only a fraction of the total deposit. It was probably the largest eruption that occurred, but it's not necessarily the most dangerous. If people had been around during the earlier eruptions, they could have suffered as well. Okay, I think looking at the scoria down there of unit E, and then up here, this is I and J1. You can see that the volcano has impacted people in some negative ways, but I don't want to leave you with a negative impression. It turns out that the volcanic ash that's erupted during these explosions, particularly the big explosions when the ash can be blown by the jet stream toward the southeast, the ash has produced deposits that have been important for agriculture by Hawaiians, pre-contact agriculture in Hawaiians. Imagine you have a bare pahoehoe surface stretching for miles. Pretty hard to, manage sweet potatoes and sugar cane and so forth on that. May be able to do it in places, but then you put some ash on there, you get a nice soil developing, and that's what made it possible, I think, for Hawaiians to have their agriculture as you get into the ahupua'a that are southeast from here, between here and Kalaupana. So, as the explosions that would have been devastating at the summit are beneficial in the far field. Okay, you guys have any questions now? Yeah. Okay. Okay. Well, let's go over and peek into Keanakako'i Crater. This is Keanakako'i Crater. That means the cave or the place of adze. The cave place, ko'i is adze. This pit crater formed probably after the caldera formed, but we don't know how long afterward. Maybe contemporaneous with the caldera, the collapse. Kīlauea, the double craters there, may be similar in age. We just don't know. It's hard to date a hole. Hard to date a hole. The crater has its name because there are stone tools that were purportedly made from a fine-grained rock in Keanakako'i, cave of the adze. Now, I don't know of a single lava flow at Kīlauea that would be fine and even enough grained and free of vesicles in order to be a good parent material for making stone tools. On the west side of the caldera, there are more than 100 workplaces that have been found by archaeologists where Hawaiians chipped away at fine, even-grained, thermally metamorphosed ballistic blocks that were thrown out. They didn't use lava flows at all. It was these ballistic blocks that had been thermally metamorphosed to for their tools. Here, I can't imagine lava flows in the wall of Keanakako'i being good enough for tool making. Now, it could have been that there was some intrusive rocks down there, fine dikes or sills that they found. That's a possibility. The other possibility is that there could be ballistic blocks in this area, and I've shown you some of the ballistics that were found by the Hawaiians to be good parent material for stone tools. So this could have been the area around the crater that had this good rocks, and so the crater became the site of the adze. Or so there could have been some blocks that fell in the crater, for that matter. We just don't know. This is something that we'll never figure out, I don't think, because there's been enough infilling of the crater since the area was being used for tool making. So we just don't know. But I'd like to raise the issue with archaeologists is that it's not entirely clear as to exactly what was going on here. Now, as you can tell from looking at the crater and what we've seen around here, this crater must be a collapse feature. Just as the caldera is collapse feature, so the pit craters are collapse features. The alternative is that these features were formed by explosions. Now, there are explosion calderas, and one of the best known ones is Crater Lake in southern Oregon, where the material that was erupted from the caldera has about the same volume as the caldera itself. And so this suggests that the caldera formed because of the material that was exploded from. But around here in Hawaii, you just don't have evidence of explosive activity around calderas and craters. You would expect a raised rim of explosion debris around the caldera or around the craters, and you don't see that. So that's the evidence that these are collapse features. It's not entirely clear what these features collapse into, but I subscribe to the old view that they collapse into evacuated magma reservoirs, just like Halema'uma'u collapsed into the partly evacuated summit reservoir. But there are other hypotheses as well. So this is the last eruption that occurred in here. Most recent was in July of 1974. That's the same date for the spatter rampart that we looked at. In fact, the eruption sort of began here and then migrated into the caldera, as well as migrating down the East Rift Connector down to Luamanu, into that area. So it's quite an interesting eruption. So with that, this is the end of the formal trip. I'll walk slowly back. If you want to hear a story at the end, just go ahead of me and then just stop at the gate. Wait for me to catch up at the gate, and I'll tell you a story that sort of puts the icing on the cake, maybe. In late May and into June, we were having once or twice a week evening meetings with the people who lived in Volcano Village. Meet at the Cooper Center, and park people, and sometimes county people, USGS people. After one of those early meetings, I'd given a presentation, and I told people that I was sitting at a dining room table in the Volcano House Hotel, looking across the rock wall, watching what was happening in the caldera. So after the meeting, a Hawaiian woman came up to me. I didn't know her, and she asked me, Don, could you do me a favor? And I said, well, yeah, what is it? So could you put this koa, false leaf, on top of the stone wall in front of the dining room for me? She had collected it from in front of KMC, and I guess had pressed it, and they say, and I said, sure, I'll do that. So she gave me this koa thing. Well, the next morning I arrived at the dining room and had forgotten about it, and then I'm sitting there, and then I remembered. So I went back to the car and got the false leaf, and I put it on the rock wall, put a couple of small pebbles on top of it to keep the wind from blowing away. I took 2 or 3 steps back toward the stairway that went into the dining room, and we had one of those 5.3 earthquakes. I mean, it was strong. I grabbed onto the railing of the stairs and, really shaking like mad. Well, so after the next meeting, this woman came up to me and said, Don, did you put out the koa thing for me? And I said, yes. And then I explained to her what happened. And she said, I have chicken skin. I have chicken skin from this. And then after the third meeting, she came up to me and said that she'd told some of her friends that story, and they got chicken skin too. To me, this really illustrates the importance of how Pele can be important to some people, to some Hawaiians, that the offering was for Pele, and Pele was responding by the earthquake. And to me, that kind of illustrates in a microcosm how important the volcano is to a certain segment, probably a fairly large segment of Hawaiian culture today. So that's my story. I think it's kind of a nice one.